Okay, here we are, the 5.6 notes, rational functions, page 4. Oblique asymptotes. I do not believe you're going to be asked to create. I will not ask this on the first exam. No, I won't ask it on the final either. But it's kind of nice to know what's going on. So we talked about horizontal asymptotes, but here's the one case when the asymptote will not be horizontal. So we have got our h of x. 2x squared plus 3x minus 5 all over x plus 2. Now what we want to do, and we're going to see what you remember here, is we're going to actually go ahead and do long division with our polynomials. I got 2x squared plus 3x minus 5, and then we're going to go ahead and pull everything together from this section because you do have 5 steps down here, which is a great way to look at when you are graphing these rational functions. And then I'm pretty sure there is one in the, never mind. Okay, so first things first. The nice thing about long division with polynomials is that we can always knock off that first term completely, and that's the ideal. So I'm going to start by taking a look at my first term here, x, and figuring out what I have to multiply it by to make 2x squared. I want to get rid of that 2x squared. So I am going to multiply by 2x. So I got 2x times x plus 2, and then I'm going to do one of the things that we should do when we did long division with numbers, but we don't ever. I'm going to go ahead and just show what I'm multiplying here. So I got 2x squared plus I got 2x times 2, which is 4x. Now, just like with numbers, I'm going to subtract this whole thing. But rather than putting a minus out front, I am going to, we're going to make it nice and red. I'm going to subtract both parts, which makes it a little easier for me to figure out what's going on here. So I got 2x squared minus 2x squared. That gives me a 0 here. I've got 3x squared minus 4x squared, so that's minus 1x. And then I'm going to bring down the 5 part. So now I got to figure out what to multiply positive x by to get minus x. And so that's just negative 1. So I get negative x minus 2. Again, I am subtracting them both. So subtracting a negative makes this plus x plus 2. Negative x plus x is 0. Negative 5 plus 2 is negative 3. So my remainder is negative 3 over x plus 2. Remember, sometimes we write a remainder as remainder 14. Sometimes we write it as 14 over 37, whatever we're dividing by. Okay, this 2x minus 1 that's our slant asymptote. So 2x minus 1, I got an intercept of negative 1, slope of positive 2x, so up 2 over 1. Here is what my slant asymptote looks like. Now, just like with the vertical asymptote, my graph is never going to cross this. Okay, so now I've rewritten h of x as 2x minus 1 plus, and I'm going to keep it this way, negative 3 over x plus 2. Now I am going to use this part right here to find my vertical asymptote. I know if x plus 2 cannot be 0, x cannot be negative 2, so my vertical asymptote is at x equals -2. Guess I should go ahead and label both of these. Now I just got to figure out what the rest of my graph looks like. I have two asymptotes. My graph is not going to cross. I could start by just plugging in 0. And it's easy enough to do this in the original function, right? Because anything that's got a variable is just going to go away. Oops. So I get -2.5 right here. So I can't cross the asymptotes. I don't have a horizontal. I'm going to make it fit. Now I just need one more point to figure out what this looks like. And in all honesty, I know that it's not going to be up here, right? Because that green part of the graph already covers the -1 and down to -2 part. So I am going to try -3. Because I'm limited on space here, -3 squared is 9. I'm going to shortcut. Plus 3 times -3. So I got 18 minus 9, which is 9. 9 minus 5 is 4. So at -3, I get -4. So -3, -4. That makes sense. We're going to come out here and up this way. Now, because I have not talked about this since page 1, let's talk about end behavior. And let's see if we can get a new color so we can make this obvious. Okay. We are going to start, I guess, at the left end. So here, as x goes to -infinity, look at what y is doing. As x gets, sorry, I missed that. As x goes to -infinity, my y, my f of x, is also going to -infinity. Okay. We have got this part here. As x goes to +infinity, let's see what's happening with our graph here. Y is increasing without bounds, so f of x also goes to +infinity. And then we got to take a look at our vertical asymptote. So this part, as x approaches, what is this? -2 from the left, which feels really weird with that double negative in there. Our f of x is going to, well, as we get closer and closer to -2, our y is shooting up to +infinity. And then the other side here, as x goes to -2 from the positive side, f of x is heading down to -infinity. Okay. So at the very end here, as we wrap this up, there are 5 steps to go through when you are graphing these. Start by finding the vertical asymptotes, looking at the zeros in the denominator. Okay, there is our step one. And it's always pretty easy to find those. Sketch those vertical asymptotes, make sure they are dotted lines. Remember, those are your boundaries for the graph. They're not actually part of the physical graph. Okay. Second thing we're going to do is find the horizontal asymptote. Keep in mind we are comparing degrees of numerators and denominators. And then we are looking for zeros. Any zeros are of the function. Keep in mind those are our x-intercepts. Right, that's going to be where the graph crosses the x-axis. And then you're looking for f of 0. That's your y-intercept. And then we're going to find a couple of other values just so we know the general shape. Again, you don't have to use a ton of values. You do have to be able to evaluate a function at a certain value. And all of that has to be done by hand for this class. Cannot use a graphing calculator or Desmos to crank these out. So a lot of times students who get really comfortable using Desmos, especially in the online class, will just kind of try to copy from Desmos. If you cannot show me where your asymptotes are coming from, where your specific points are coming from, I can't give you credit. So definitely reach out and make sure you understand this. If there's anything you're getting hung up on, ask.